Good afternoon. I'm Chris Wilson. I'm a developer advocate on the Google Chrome team. And I'm here to talk about plugin-free real-time communications with WebRTC. Now, before I get going, this entire deck is already posted. It's actually a slightly modified version of a deck I gave a week or two ago at a local meetup. It's already posted on the web if you want to follow along. Or refer to things later, because I'm going to run through a ton of detail, and there's a bunch of links in here that are really interesting. I'm not going to leave them up on the screen for very long. Just remember this. It's also at the end, so don't worry about writing it down right now. See if it's actually worthwhile first. So first of all, I want to talk about what WebRTC is and give you some kind of context on what I'm talking about. So WebRTC is a collaboration to build real-time communication into web browsers. It's a response to the demand for real-time communication features, but in the open web, without plugins, proprietary codecs, free for not only users, of course, but developers to use. So you have the ability to build real-time collaboration features into your projects without having to pay for a proprietary codec or anything like that. This has been a big missing feature in the web platform. This has typically been something you use plugins to do, or something that you use proprietary native software to do. And before I go any further about WebRTC in particular, I need to state that WebRTC is about peer-to-peer communications. Obviously, you can use peer-to-peer communications to build larger groups of communication, but WebRTC itself, like the protocols and the setup, is designed to be a peer-to-peer system. This means that, in the past, a lot of real-time communications was based heavily on server managing communications. So a server being responsible for piping all the media through and that sort of thing. That's not the way WebRTC works. It's really inefficient and expensive to run a service just to relay media or communications if you don't have to. Obviously, some of the time you do. So WebRTC is really nice and friendly, big fluffy cloud in the middle. As you'll find out later in this talk, it's not quite that simple, but I do want you to keep this image in mind because I find the fluffy cloud very calming. So the next thing is when I say WebRTC, and you'll see the progressive layers of the complexity onion being peeled away here, WebRTC is actually a collective solution. It's not just one standard or one specification or one piece. It's actually built on this wide litany of a bunch of different pieces coming together. The base RTC web and session protocols that come from the IETF. WebRTC, there's a spec named WebRTC, and media capture and streams from the W3C. There's the libjingle library for doing XMPP-based peer-to-peer management, and the VP8 and VP8 video and Opus audio codecs. All of these pieces have to come together in order for real-time video and audio collaboration to work. So this may seem, now that I've dumped a whole bunch of terms on you and pieces that are required, this probably sounds super fragile. Like this is supported on exactly one browser out there, and it only works on one device, one set of hardware. But that's actually pretty far from the truth. And I'm relatively new to WebRTC. And I was really surprised at how broadly it was already implemented. So WebRTC actually is already shipping on Chrome, Chrome for Android, Firefox, Firefox for Android. Opera has had an implementation for a while. And we also have native libraries for both Android and iOS to incorporate into native applications on those platforms. In fact, we're going to give our first test of this guy and see if we're going to test how good the Wi-Fi is in here. I actually am on a different Wi-Fi at least, so hopefully it will be not too bad. But I want to prove that I'm not just making things up. So rtc.appspot.com. Oh, come on. You know what? Let's do this. It's going to be easier for me to 712.27546. Hey, there we go. So you can wave to yourself now. Wi-Fi is not doing great, but these are currently connected on the same Wi-Fi network. If I get brave later on, I may do this on my cell phone and show you that it actually does connect there as well. But the key point that I want to get across here, another thing, the Qt engine is also moving to Chromium, which means that they also pick up WebRTC. Qt is a framework for building cross-platform, device-native, and embedded applications, so they'll also pick up WebRTC. And when you put all of these different endpoints, all of Chrome for Android, Firefox for Android, Opera, the frameworks, et cetera, together, we actually currently have over 1 billion WebRTC endpoints, like over 1 billion users who already have WebRTC capabilities on their systems today. Like they already have all the pieces there and functional. Like this is an amazingly large number. So you can tell it's really a huge opportunity, and it's not an opportunity that you need to wait for. Like the number one thing I want you to take away from this talk is you can actually build on WebRTC today. It's not something that's only for the future. In fact, back in August, V-Line facilitated the first live TV interview done via WebRTC on Sky News. So they actually had a setup, instead of a setup like this and a bunch of really big cameras, they had a setup like this. Like this actually was a photo of their setup, like standard video podcasting rig, basically. And they interviewed this person running it via WebRTC over their standard network to the TV studio where they incorporated it. So that's kind of the vision, like taking all of this real-time communication stuff that's been very proprietary and very specialized in the past and pushing it into the open web platform. Now I want to talk for a while about how this works, how WebRTC fits together, all the pieces fit together. So for real-time communication, there are really 4 main tasks that you have to do. You have to get access to the local audio and video on the machine. You have to acquire access to the webcam, access to my microphone, all that sort of stuff. Then you have to establish a connection between peers, and we'll talk about that for a little while. That's actually one of the hardest things to do. Then you have to do the communication of video and audio. You have to stream video data from my webcam through this connection to my friend's computer. And another step that's an interesting side note at this point is communicating arbitrary data. Like you don't want to just use this for video and audio data. You actually want to communicate other types of data as well. You could use this to build a game on top of and send all of the data about where all of the other players are, or what's going on in the game world, as well as streaming audio and video data to other players. So to accomplish these 4 tasks, there are actually 3 main JavaScript APIs or API sets. There's this thing called media streams, and we're going to talk about this in the context of getUserMedia. This is how you get a media stream. There is RTCPeerConnection, which is the piece that actually lets you build a connection between 2 computers and then gives you the endpoints to attach those streams to, so doing the communicating video and audio data. And then finally, there's something called RTCDataChannel, which is how you communicate arbitrary data back and forth between peers. So we're going to jump in to media streams. And this is one place where I'm not actually going to be as network focused. I'm going to show you some demos and things that are actually mostly local, just showing you what kind of access you have to the local capabilities of a machine from the web platform. And keep in mind, this is all just running in the browser. This is a nearly brand new laptop, so it doesn't really even have hardly any plugins or anything installed on it. I just got this like a week ago, and it's still not totally set up. So let's talk about media stream, because media stream is kind of the fundamental piece that you need to use to grab hold of a stream of media, obviously. This represents a stream of synchronized media. It can contain multiple tracks inside it. So if I grab the local webcam, I probably actually have an audio track along with that. It ends up being in the same stream at that point. It can contain multiple audio tracks. It can contain multiple video streams as well. So it's possible to push multiple streams through this all at the same time. But the way that you get one of these is with this neat little API called getUserMedia that shows up on the navigator, and if you're familiar with JavaScript APIs. And it's actually pretty straightforward. If you know JavaScript pretty well, like how many people are not super familiar with JavaScript? And this is kind of like, I just said, well, it's really easy, and I put up, Einstein's theorem proof or something. OK, great. So techie crowd, you get the idea. You basically build an object that says, these are the constraints that I want. In this case, all I'm saying is I want video. I don't want audio. I just want video. So I say video true, and then I hand that to navigator getUserMedia. And I give it a success callback and a failure callback. And you may have noticed, which I guess you didn't notice on the PC, because I think I used HTTPS. You may notice you'll get a pop-up that asks you, is it OK to do this? Is it OK to give access to the webcam? And I'll talk more about security in a little bit. But then, of course, you may get an error, in which case you'll give it back. But if you don't get an error, you get past a stream, and then you can do interesting things with the stream. So the most basic thing that you can do with the stream is basically just assign the stream to a video source. So stick a video tag into your page, a video element into your page, assign this source to it, and you'll get something like, there's my pop-up. If, hey, cool, no camera. OK, well, you're supposed to be seeing my face, but apparently it's not finding my camera for some reason. And I'm not going to reboot my, well, I may have to reboot my computer. Hang on. Let me try rebooting my browser at least. Sorry about this. Swear I just tested this. There we go. Oops. OK. So this page is pretty simple. All it has is a video element on it. I call navigator getUserMedia. When it returns me a stream, I assign the stream to the video source. And you get me. But you'll notice, by the way, it did pop up a security box. If you run with HTTPS, you actually only get prompted once for this. So if you use HTTPS as a transport, and the user has said at some point, yes, it's OK for this site to get access, it won't ask again. Likewise, with Chrome applications, if you've packaged this as a Chrome app, you can ask for audio capture and video capture permissions. On installation, it will ask you, is it OK if this app does that? And then it doesn't ask again. You can't get to getUserMedia from Chrome extensions, things that sit there and run all the time for somewhat obvious reasons. Although that may change in the future, I'm sure it would be a pretty big deal security-wise. You may also have noticed when I had that open. Let's reopen that guy. When the camera is active, there's a little camera icon right here that I clicked on once. It actually lets you change settings or say, I don't want you sharing with this site ever again. And you can go straight in and manage your other settings as well. Another word of warning, as you start looking at WebRTC, like many other interesting application-y APIs, you have to run this from a server. You can't run this from a file URL. You can't just open index.html as a file. You'll get a somewhat baffling permission denied error. They're actually working on making that better. But a lot of Chrome APIs, or a lot of application level APIs, like Web Audio as well, does the same. You have to have access to, you have to run it from a server rather than a file API, a file space. Now, the interesting bit, though, is not just sticking a video element on a page, because that's actually kind of boring. So you can actually plug this into other APIs. In this case, this one pulls in the frames and captures the frames, analyzes them for color data, and turns it into ASCII art for every frame. So you can actually see it move as I move around. The main point of this is just that you can actually process the stuff that you're getting in. You can get access to the bits. You're not just, hey, this is an opaque stream that you can only pipe to the other end. Now, anybody who has heard me speak before probably knows I love audio stuff. You can actually do this in the same way to get access to the bits for web audio. So you can get access to a microphone input or any actual audio input that's plugged onto your computer. You can use it to get access to that and pipe the bits into web audio, from where you can do pretty much anything, anything that you want. And I think I actually can do this demo for the first time because I was playing with it. It had a tendency to feed back really badly. But I think that I fixed this, so we're going to give it a try. You want to go ahead and kill my mic? OK. Go ahead and turn my mic back up, and I'm going to kill this guy. Now, this is a demo that I wrote a couple of years ago now, actually, for I/O that actually builds a vocoder in web audio by setting up a whole bunch of nodes, this huge network of nodes, and then basically just letting it process audio that gets fed through it. And I wrote this as a live, real-time audio processing system, knowing that eventually we were going to get the ability to do live input. And the minute that they actually turned on live input, and I got a build from the developer who was working on it, I ran over to my computer, and my wife was like, aren't we eating dinner now? But for the next 45 minutes, I was coding it up and getting it working. And now I can actually show it off, because I got it to stop feeding back. Now, the main thing that I want you to take away from this is you can get these sources locally and do interesting processing things on them. The really cool thing is you can actually get these sources locally, do processing on them, and then pass them off to WebRTC, to your stream connections. So I can make it so I have the vocoder on my voice during RTC peer-to-peer video talks. Haven't actually hooked that one in yet, but it's actually not that hard to do. Now, there are a bunch of other pieces, a bunch of other things that you can do here with getUserMedia. I'm not going to go into a ton of detail. I'm not actually going to go into every single one of these demos. This one in particular basically is just to let you know that you can use constraints also to say, I want a low-resolution camera image rather than a high-resolution camera image. You can say, I want an HD or better camera, that sort of thing. You can actually ask for particular aspect ratios, although that's not always supported by all browsers. We also have the ability to use constraints to choose sources. So if you have multiple cameras or multiple audio inputs, you can use this to hook sources. Although I will warn you right now, it's not super user-focused right now. It's like you have the ability to choose a particular source and identify the particular sources, but what you really want to be able to do is say, hey, I want the front-facing camera. You know, this is my selfie photo taker. Or this is my, you know, I want to take real photos looking away, so I want the rear-facing camera, vice versa, I mean. This isn't totally there yet. It's not been baked, and it hasn't been implemented across all the browsers yet either. You can do this dynamically from JavaScript as well. You can switch cameras after you've created a source and ask for a different one. So the last thing that I wanted to mention is you have the ability to, in Chrome, this hasn't actually gone into other browsers, and it's been proposed in the spec, but I don't believe it's been incorporated yet. You have the ability to ask for the screen as a source. So you can say, getUserMedia screen, and it will screen share. So you can use this to screen share your screen into an RTC stream. So that's getUserMedia. You actually have the access to get all of the local media. This is actually, I'd love to talk about that more, but I want to dive into the PeerConnection and data channel stuff and make sure we have plenty of time for them. So once you have the access to the local media and you can do things with it, the question is, how do you create a connection between peers? And on the surface, the API is pretty simple. You know, you get access to the media streams via getUserMedia, you plug them into a peer connection, and they just get sent to another WebRTC endpoint somewhere. But in reality, it's a lot more complex than that. Under the hood, RTCPeerConnection has to do a ton of stuff. It has to, you know, it does things like processing the audio and video to remove noise and compressing the data using codecs adaptively, and setting up the peer-to-peer pathway through NATs and firewalls, encrypting the data, making sure you're not, you know, using too much bandwidth and things like that. Now, thankfully, using RTCPeerConnection, a lot of this complexity here is abstracted away, which is why I'm just putting this up as an eye chart. I'm not actually going to walk through every single piece of it. But it is a little bit more challenging. So there's that nice fluffy white cloud that I showed you earlier. And what it didn't actually say was, even though we're peer-to-peer, we still need servers. And the reason why we need servers is because it's not really scalable to just kind of shout into the big internet, I want to exchange streaming data with my friend. He's over there about 700 miles. Like, you actually need to communicate between each other, and he may be on a totally different system, a totally different device that supports slightly different codecs even, but certainly has different parameters that it wants on those, like wants a different size image or things like that. So you need to negotiate this connection. And negotiating the connection is where signaling comes in. Signaling is the process of coordinating the communication channel, figuring out, first of all, how to drill through network address translation and firewalls that are in the way, because of course you probably have a home firewall, and your buddy at the other end of the connection probably has a firewall as well. And you need to be able to exchange these session description objects that figure out how to get through those and how to navigate through them. You also need to talk about what media formats you support and that sort of thing. Now, signaling, you can use any mechanism you want to do signaling. The details are actually left up to your implementation. It is possible to build a WebRTC system. In fact, there's some demos of this where they don't even have a signaling mechanism. But then you have to hard code everything. Like, you have to hard code, I'm going to run at this resolution, this codec. There's no network firewalls anywhere in the pathway or anything like that that I need to worry about. And of course, that's going to fall down pretty quickly. Like, it may work when you and your buddy are using the same device on the same Wi-Fi network, but it's not going to work in most other scenarios. Now, this is where the JavaScript session establishment protocol comes into play. So the caller sends this session description to a signaling server, again, a nice fluffy cloud, and it forwards this on to the callee, and the callee sends its session description back, and they kind of collaboratively figure out what they can do together. And then once they've actually figured out how they can connect, the server is no longer in play. Like, this is not a fixed server, by the way, and I'm going to talk about that in a minute. But the actual media never goes through the server. The media is sent peer-to-peer. So the actual communications after the establishment is all peer-to-peer. Now, RTCPeerConnection does take care of this initialization. It can check the local media capabilities for you, the network landscape, and that kind of thing. And we have the simple peer-to-peer link here is the one that has like predefined signaling in it. But you can also use Node and Socket.io to do a signaling server. You can build these in a whole bunch of different ways. There are a bunch of the main code lab that we did at I/O 2013 was actually building a signaling server. So it's a great code lab to go look at if you're interested in doing code labs. You may also find that it's easier to let someone else deal with this for you. But this is not, as I actually had a question about this last night. So this is all sent to a Google server then. I'm like, no, we don't run the server at the other end that you're supposed to do all your signaling through. You tell it where to go. Like, this is your connection, your application. We don't build these for you, although we do have a code lab that shows you how to. Now, the session descriptions that you're exchanging look something like this. They basically say what kind of audio codecs you can do, what your network looks like, and that kind of thing. WebRTC is designed so that you're basically making an offer of what you can accept, and those can get tweaked before they're actually set as the actual description of the object. This is why we have candidate objects that actually say this is a candidate, and basically they go down and both sides choose the first one that they can support, and that's how they get a connection. Okay. Incidentally, very recently, there is the ability to plug RTC peer connections together, use the output of one RTC peer connection as input for another. This basically lets you build an application that is like a switchboard. So you can build this as a server application, like build a node server that can do this, or you can even do it on the client and connect other people together if you're interested in doing that. Now at this point, you're like, I'm really confused by signaling. My head really hurts. I don't understand even the concept of what signaling is. Well, this is kind of where I was several weeks ago. And this is why I did want to point to the example I was talking about before. You can do this without any signaling whatsoever. And it's a good way to learn about how to use a peer connection to communicate first. But again, the code lab will actually lead you through building a real application. This, by the way, is what I brought up before. This is kind of once you've wrapped your head around how signaling works, or sorry, how the peer connection works for communication, this is where you want to go poke at how to do signaling and do communication back and forth. Okay, so the last piece of this puzzle, the last piece of WebRTC, of real-time communication, is the RTCDataChannel. And DataChannel is a really flexible API as well. The interesting bit is, well, let's get into this. So the whole goal of RTCDataChannel is to let you communicate arbitrary data. Like, if I want to build a video game and communicate back and forth where the pieces are, where the players are, that sort of thing, I can do that very easily using RTCDataChannel. The really cool thing about RTCDataChannel, well, there's several cool things, actually. The first one is it's the same API as WebSockets. Like, you use effectively the same API shape. So if you're already building WebSocket-based communications, like doing a peer-to-peer app between two different endpoints, it's really pretty easy to convert. Like, you have to work out all of the signaling bits and that sort of thing, but changing it over to use the APIs you have with data channels is actually fairly straightforward to do. The second cool thing, and to me this is one of the coolest parts of it, is it can have ultra-low latency. In fact, it can actually have lower latency because RTCDataChannel can be using, in some cases, can be using UDP rather than TCP/IP. So you can get better throughput, or not better throughput, but lower latency of your packet communications in this particular case. Sometimes that doesn't work out, by the way. It depends how your settings are, but it is a possibility at least. And the third cool thing about RTC data channels is they're actually secure by default, and I'm going to get into that more in about 2 slides, so keep that in mind and we'll come back to it. So this is the RTC data channel API, or an example of the RTC data channel API. Once you have a peer connection set up, you set an on-data channel that's the connection event. You set a receive on message, and when you want to send something, you call send. It basically really is exactly like the WebSockets API. And this is an example. Actually, I'm not sure which example this is, so I'm going to click on it and find out. Oh, yeah. So this is an RTC data channel sample that is actually built without signaling because it's actually communicating to the same system, the same place. So I can hit start. This creates a data channel between me and myself, effectively, and type something, and it moves it across to the other side. The interesting part of this, of course, is it's actually moving it using RTC data channel. So go poke at the code and you'll understand more of what it's actually doing. I want to jump past that app. So I want to talk about security for a minute, because this is surprisingly to me, actually, because I didn't think this would be the first question everyone had. This typically is one of the very first questions that people have about WebRTC. Now, the neat thing about WebRTC is it actually has security built into it from the very ground up. All of the media and all of the data that's being exchanged using WebRTC is already encrypted. It has a secure channel. It's basically using, effectively, it's like using HTTPS for all your communications. Of course, we require this opt-in from users before we turn on their camera and their mic and that sort of thing. WebRTC also runs, of course, in the Chrome sandbox, so it's keeping it sandboxed from other system stuff as well. However, signaling mechanisms, again, as I said, they're kind of up to you. Like, you can use some somewhat standardized pieces to build these, but you're responsible for building how your signaling works. And it's up to you to make your signaling secure, because otherwise you can have a situation where you let someone else insert themselves into your signaling mechanism, and they set them up as a man in the middle, and they can redirect your connections, forward your data, all that kind of thing. So you do have to be somewhat careful on the signaling side that you're staying secure there as well. But the actual paths that you use to communicate audio and video are encrypted, so they're secure from endpoint to endpoint. You just need to make sure you're going to the right endpoint. Oh, wait. Yeah, sorry. Stop that. So finally, I wanted to talk about voice applications, because I wanted to make sure that you understand this isn't just video. Just like I said, it's also data communications. You can also use this just for doing audio communication. So you can use this as a way to basically replicate a telephone connection from point to point, from peer to peer. So it's pretty easy to set this up and do, like, player-to-player communications between a game, for example. The interesting thing about this quote, this came from a deck that a coworker of mine wrote about WebRTC. And I read through this, and I was like, well, that's kind of an interesting quote. And then I saw who made it. this is the chief technical officer of the FCC, the Federal Communications Commission, like the guys who control all communications, in effect. And I thought it was amazing that they got this, that it really, voice at this point is becoming just another feature that's built into the web framework. So the other point about voice is that because of the way WebRTC is designed, it's not just about browsers, on video as well as with audio. So you can build a device that just has WebRTC in it. And obviously, you have to make sure it has the same signaling mechanism. But if it has the same signaling mechanism, you could build a phone that just has WebRTC audio built into it, basically. Doesn't have a browser for you to use, but it has all the WebRTC bits. And in fact, that's pretty much what Zingaya has done. So you can go check out their work. As you start poking with WebRTC, the one place that I really want to encourage you to go is, first of all, of course, I think I'm contractually obligated to say you should use Chrome, because Chrome's awesome. It's the only time I'll say that, though, so it's OK. Chrome://WebRTC-internals. This is one of our debugging pages. This really gives you a ton of information to debug your WebRTC. You can see what's happening on your streams, how many bits and packets are getting moved across and that sort of thing. When there are errors, this is a great place to start debugging what's going on in them. We also have a library that's out there that lets you use the same code in all browsers. This is because there are still some vendor prefixes. I think they've actually almost all gone away at this point. There have been a couple of Chrome and Firefox differences, but I think they're pretty much nailed at this point. But it also is designed to minimize the effect of spec churn. So as WebRTC changes any, it would get reflected there. If you plug this in and write using adapter.js, it will help you out. Now, at this point, my brain actually exploded by the time I wrote this several times over. But there are a lot of frameworks and examples out there to help you with WebRTC. Obviously, the simple WebRTC is a really good place to start. But beyond that, there's EasyRTC, WebRTC.io. The code lab that I pointed to earlier in the deck is a great way to really dig into signaling and how that works. Lots of peer-to-peer data examples out there as well. Tons more information. Again, the whole point of putting these in here is because you can go to the deck yourself afterwards. Lots of places to discuss this on WebRTC.org. Actually, WebRTC.org is a great, just centralized location for a lot of this information. And fundamentally, what I want you to walk away with is WebRTC actually gives you the ability to take advantage of real-time communications in the browser platform. It's kind of up to you what you do with that, because you do have video and audio, but you also have arbitrary data channel that you can use and build whatever you want on it. And with that, once more, this is the link to the slides, so you can get to all of the resources that were in here. And I think at this point, I've got plenty of time for questions. There are microphones on both sides if you have questions. That way I can take a drink of water and not have to repeat them.
OK, so let's say I'm building an app. Let's call it Chillouts. And it has, it has several.
Like the name, catchy.
Yeah, catchy. So it has several different videos from different sources on each screen. And let's say I'm using this app on a Wi-Fi connection that's not great. Does this stuff have built-in, I guess, stuff to make the quality lower, or is that something I have to manage myself, and what kind of tools do I have to do that?
So the initial, there's some part of that happens in the initial setup, but there is, the video streaming does have adaptive streaming in it. Oh, come on, I had more questions than this in the Lightning Talk version. Yeah?
You were using that pairing server on AppSpot. Was that running on App Engine, or was that on
Yes.
Node? That was on App Engine?
Yeah,
What,
the code, the demos here are running on App Engine, although I think, I mean, it's basically just using it as a Python server.
Okay.
At that point.
There's no special socket library for Python, or do you have to?
I
like, is it
actually
using Web app
haven't
too?
looked to see how they were doing it.
Okay.
Yeah.
You mentioned screen capture being only supported in Chrome right now.
Yes.
Can you expand on that more? Are there, is there going to be sort of a fight around that? Is there an alternative method that should be considered for
Sure.
more cross-browser?
So as far as I know, there is not another proposal on doing screen sharing. I think the Chrome guys, the WebRTC team in Chrome, looked at it as, you know, if we think about everything that we need to be able to do to really do all of our real-time communications through WebRTC, one of those pieces is screen capture, like screen sharing, because it's a super common thing to do. We actually, inside Google, we've used Hangouts, obviously, for a very long time now, and we use them very heavily for communication internally. But the interesting thing to me is that in our conference rooms, we have big monitors in each of the conference rooms to present to other people. The interesting bit is that although they usually have one of these dongles connected to a HDMI or VGA connection, they don't work very well. In fact, I can't get one to work ever anymore, and I've given up because what you do is you just fire up a Hangout and screen share from your laptop. And in fact, usually there's one guy in the meeting who is on it twice because he's on the system and he's sharing from his laptop to show things off. So they looked at that, said, hey, we really need screen sharing. They added it. I think it's going to take a little bake time to get adopted, and it's possible other people will have feedback about how to do it. Because that's another place where you need to deal with things like different screen resolutions and things like that.
Is there a timeline for that you're aware of?
I don't know. I'll have to check. Yeah?
So you mentioned earlier about security. Clearly there's a browser prompt for webcam and microphone access.
Mm-hmm.
There is no prompt for data channels, which means you can spin up a data channel hidden under the covers and nobody knows. Now I've heard that there's conversations that have happened and they've determined that that really isn't a security risk, but I was wondering if you could speak more to how is it okay that a data channel can be spun up without the user knowing?
Mm-hmm. So when you spin up a data channel, you can spin up a data channel, but if no one's listening for it, it doesn't really matter. Right? This is kind of like the problem is not that you can ping somebody's server and try to connect. It's that you can actually connect to some services that are listening on those. And with the data channel, your app needs to have either set up that data channel receiver on the other end, or if it didn't, it doesn't do anything. It doesn't go anywhere.
Yeah, but what I mean is two users show up on the same website, and that website under the covers hooks those two users' browsers up
okay.
and starts communicating data without either of the users knowing.
Interesting case. I can't see anything that you could get to in that case that you couldn't get to by connecting from each of those users' clients to that server anyways. I mean, once you have a connection between a server and a client, anything you can get to on the client, you could push to the server. So you just have to be careful what you can get to on the client. Like, I don't think there's anything specialized there. Like, how could you push anything other than what you could, post back to the server, even for that matter?
Access to client-side cookies that you wouldn't necessarily have access to in the server. And you could push those between users.
Yeah, we should talk afterwards, but I don't think there's anything you can get to that you can't otherwise. Like, there's no special sauce about being a data channel. Yeah?
Chris, hi. I missed most of your session, sorry, but a couple weeks ago there was a hack day at MuleSoft, and it was interesting. We did some WebRTC with some mobile devices, and the results were interesting. There's a combination of some CSS3 3D animation with a kind of a cube thing with the video stuff. The results were just real brief. On an iPhone, the graphics worked, or the video, but together it all just showed black. On a Samsung, it worked flawlessly. On an Nexus 7 II, most of the time it just showed the graphics. A quarter of the time it showed and then half of that time it crashed the actual device. So when we filed crash reports, there were some Chrome guys there. Do you know anything about when this will become kind of stabilized? And the other separate is, it should work with Google Glass as well, right? You could, because it's ice cream sandwich.
Okay, so let's deal with the glass question separately,
Sure.
As best I can. On the other question, I think that you'll find the stability and interoperability has been a challenge. It's been getting better rapidly over time. I mean, this is most of what the team is doing now, actually, is trying to work these issues out. One of the biggest challenges here, of course, is the fact that you don't have WebRTC in the web platform on iOS devices. So what you're using has to be the native library that we build for iOS. And it too, like this is something that Google is investing in and spending our time and effort developing, even though it's not really directly available in the web platform. But at least iOS native app developers can use it. You can even develop using that and embed a web view and use that together. But in fact, OpenClove is actually doing precisely that out on the exhibit floor right now. I think you'll probably find that the results improve pretty rapidly over time. And the biggest drawback right now is the missing in the web platform bit. So Glass. Glass is a good question because I actually don't know the details of what they're using for their browser view, but I'm guessing that they're going to want a native application version just for pure performance reasons on their system. I know that Glass is one of those things that they've had to do things to get it up and running, and now they're starting to go back and redo it exactly the way you'd want it in a real production system. So I think at some point that's going to change over, and the answer to your question will be, yeah, it's just another device, and it works just fine. But I'm not sure what state they're in right now.
Okay, thank you.
Yeah?
Just quickly, what are the developer tools in Chrome? Can you actually see packages or stuff moving back and forth?
So you can see the connection data moving back and forth. You can debug the packet communications. I don't recall if you can actually see like the video stream data in that page. It's more analytical than that.
Okay, so just like the initial connection.
Well, I mean, you can see the data statistics over time too. So you can see how much bandwidth it's using up and that sort of thing.
Cool, thanks.
Mm-hmm. Yeah.
Hi. What kind of signaling does it use? Is it zip-based, or how is it?
The signaling, again, like you can write your own. Typically, you're using stun and turn to do signaling. It really depends on what you're using on your signaling server.
Can it be used with zip? Are there any integrations with zip already?
I don't know if anyone's using SIP particularly to do it or not.
Okay, thanks.
Yeah.
Hi. In your examples, you had one-to-one peer connections. How many possible peer connections can, say, Chrome handle between, if you
Great
had a
question.
hangout of like 20 people?
So how many peer-to-peer connections can you handle on a single machine? I'm going to not answer your question first, and then I'll give you an answer to give you an idea of it. It really is very dependent on your local conditions. I mean, if you're sitting on a fiber optic pipe and everyone else on your system is on a fiber optic pipe, you could probably get quite a few connected. In the real world, particularly if you're talking about a mobile device and a high-resolution stream, high definition, lots of stuff going on, you're going to start falling over after you add 3 or 4 users. You're not going to be able to keep up full streams on all of those. That's why typically for any kind of like multi-person, multi-peer connection, you will end up with a topology where you send everything to some centralized system that collapses down what it's actually doing, like what data it's actually sending, so that it can stream just one stream or 2 streams to you. that are cut down versions, and it knows how to switch between who is most interesting to look at or whatever during that.
Thanks.
Now, if you can play other games and figure out how to shut down or turn down some of the streams, you could probably get around those limitations too. So you could improve it, but realistically, if you're trying to connect to more than 3 or 4 users, three or four peers at a time from one machine, you're going to have challenges, and on a mobile device, it might even be lower than that.
Thank you.
Great. Thanks very much.